How confident are you of finding an effective alternative to imidacloprid, and how soon?
In the last couple of years, I've noticed beetle numbers increasing around both our farms, where we never used to see many before. And knowing that we're going to be losing imidacloprid, we need an alternative. Seeing the neighbours plough out first, second returns, that's productivity losses, and it's going to affect the whole industry. There's going to be destruction of crops without some alternative there to control the grub levels.
I'm hoping, because we've got 10 treatments, that instead of just ending up with one single active ingredient or product, which we always have relied on in the past, that we may get more than one product.
One of the big frequently asked questions is, why haven't we disclosed what chemicals are being used in the trials? Hello, I'm Sonia Campbell and welcome to Cane Matters. Today we turn our attention to one of the most critical challenges facing the Australian sugarcane industry and a high priority SRA project aiming to help address it. Cane grubs cause more economic damage to Australian cane farms than any other known pest, responsible for tens of millions of dollars in crop losses each year. Managing them is challenging, and for 2 decades, growers have almost exclusively relied on a single insecticide, imidacloprid, to control this destructive insect pest. With a cloud currently hanging over the future use of imidacloprid as it continues to be reviewed by the Australian Pesticides and Veterinary Medicines Authority, or APVMA, SRA last year fast-tracked a project to accelerate the search for an alternative to this insecticidal control that is environmentally sustainable and long-term to ensure ongoing cane grub control. Leading this project is an expert in this research field, SRA's entomology leader, Dr. Kevin Powell, who joins me today. Welcome, Kevin.
Thank you, Sonia.
Kevin, this project is called Beyond Imidacloprid, ensuring effective and environmentally sustainable cane grub control for the future. Let's be honest, there is a lot of expectation riding on this field trial project, where you will be testing a number of alternative products to replace imidacloprid. We're going to unpack some of those expectations today, answering some of the most frequently asked questions, including where the field trials are taking place, expected timeframes, and what it all means moving forward. Kevin, logistically, this was a mammoth effort to get trial sites established because you were working within a very tight window of opportunity. What went into setting up these trials?
I guess, Sonia, I'll take a bit of a step back first. The first thing we had to do in a previous project was actually identify the treatments that could be used for field trials. So we actually tested 23 different products and have narrowed it down now to 10 for use in the field. Getting the right field trial sites was really critical for this work, because you actually need to get field trial sites where you have heavy grub damage, but you also have minimal use of imidacloprid, because you can't run field trials to test products if you've got a background insecticide level at those sites. So the first thing to do is to talk with growers across multiple regions and find appropriate sites where we could test the chemicals. We did that, and we have now identified 12 field sites. So those 12 field sites are across multiple regions, going from far north Queensland up in the Tully region and working our way down through the Tablelands, through Cairns, Mackay Central region, the Burdekin region and the southern region.
How did you select those sites?
The sites were selected. We needed two types of trial sites. We needed plant cane trial sites and first return trial sites. And we actually needed sites where imidacloprid hadn't been applied for at least 2 years. So you don't have that background imidacloprid in the soil, and where growers had historically had high grub damage at those sites.
That must have been an effort in itself, meeting that criteria, because if you've had cane grub pressure in the past, you would assume the grower would have used imidacloprid. So was that in itself a difficult task, finding sites?
That was certainly a challenge, particularly under such a short time frame, because this project really didn't get started until August. And then we had to find trial sites where we could be applying treatments starting in October, essentially. So it was a challenge, but we came up with just enough field trials for the first season of this work.
And why was there that short window of opportunity to apply the chemicals?
There's a short window of opportunity because you need to apply the chemicals as close to the planting date for plant cane as possible. So actually applying the chemicals at fill-in. So it's really, was site dependent. And the other thing is we needed to travel to multiple field sites with our application equipment to get things done in that very short period of time.
You said that we're applying these chemicals on both plant cane and first return. Why both?
Because what we're dealing with is liquid treatment applications. So growers could be applying at both planting and return. So it's important to test both. And the data that we get from this will go to the chemical companies, who then would put forward the information, our trial data, to the APVMA should they seek to go forward and try to register the products.
I understand all of those applications have now been completed.
Yep, we managed to get all the applications in on time. It's quite a logistical process because, particularly for the return crops, we wanted to use the same application equipment so that trials are standardised. So equipment would be cleaned and transported from region to region. So it's always the same equipment that is being used. So logistically, that was a challenge because we didn't have 12 applicators, one for each trial. We actually had one applicator, which was moved from trial site to trial site.
So the consistency was there with the applications, and all the chemicals in this trial passed an initial screen test, if we can call it that, in the lab to establish their effectiveness as a control. That must give you a level of increased confidence going into these field trials.
Yes, so in the laboratory trials, we actually compared the treatments with the industry's standard of imidacloprid to make sure that we weren't going to be using products which were less effective than imidacloprid. So all of those products passed the test in the lab trial, but now we need to see, do they behave the same way under field conditions?
So let's address some of our most frequently asked questions, which are shaped by the very real commercial concerns that exist in the industry around this issue. The big question, how confident are you of finding an effective alternative to imidacloprid? And the follow-up question, of course, how soon?
I guess the laboratory work has shown us that these chemicals do work under controlled conditions. So we've actually got 10 treatments that look very effective. So I'm quite confident that at least some of those 10 should work well in the field. I can't say how many until we've tested them under field conditions. What we need to be certain of, though, is that as well as controlling the grubs, these chemicals have good persistence in the soil. So it's no good having a chemical that just lasts for, let's say, a week in the soil, because it's not going to be long enough to kill the larvae or the grub stage. So we need to also ensure that they persist in the soil for long enough to control the grubs. And we'll be doing tests on that to look at how long they survive in the soil. The other thing we need to be aware of is we don't want to be using a chemical that has environmental issues surrounding it. So we will be doing some tests on leaching, for example, to see how quickly a product leaches through the soil. So it's not just a case of can we find an effective product, it's is that product environmentally safe? So because we've chosen 10 treatments, some of them we may test and, they don't persist for very long, so those won't be suitable. Other ones may persist for longer. But until the field trials are conducted and completed, we won't be able to say which treatment is going to be the best. I'm hoping, because we've got 10 treatments, that instead of just ending up with one single active ingredient or product, which we always have relied on in the past, that we may get more than one product. And that's actually really important, because if you get more than one product which acts in a different way, that means you can develop an IPM strategy for cane grubs and not have to reinvent the wheel in decades to come and say, well, let's find another product.
That is a good point, because industry would certainly like a solution that's long-term and not have to, as you say, reinvent the wheel perhaps in 10 years' time.
Yep.
The urgency of it we can understand, because it's such a critical issue for industry, but it's a delicate predicament, isn't it? Because on one hand we have this critical need to control the grubs. Then we have this pretty limited time frame to come up with an alternative solution. But then you have this regulatory reality to find something that's both environmentally sustainable and one that satisfies the compliance requirements of the APVMA to support registration of a new product. Yep. So once we identify a product, it's important to note that the chemical company that owns that product, they will need to go through the approval and registration process with the APVMA. How long does that process generally take?
The length of the process can be quite long, but it really depends on what the APVMA do as a result of the review. So if the products, and it's not just imidacloprid we're talking about, it's actually all the neonicotinoids. So there are other products used to control cane grubs. There's one other product, and that's clethiridin. Potentially, APVMA could withdraw both products, or it could have a phased withdrawal of the products. So depending on how quickly that timeline is, will depend on the application for the permit process. So it could be an emergency use permit, which takes a shorter time, or it could be a complete registration of a new product, which takes longer.
When are we expecting a decision on that?
We don't have a confirmed date from the APVMA, but we're trying to fast track so that we will have at least interim results by the end of 2026 from our field trials. And then the plan is to conduct a further 12 field trials in 2027. I can't give you a specific date for when the APVMA will make a decision, but we are in close contact with them. So once we know, we'll be able to look at what data we have and have those discussions with the agrochemical companies to try and push forward any registration process.
One of the next big frequently asked questions is why haven't we disclosed what chemicals are being used in the trials?
We can't disclose what chemicals are used in the trials because we have confidentiality agreements with the chemical companies. So working with a number of chemical companies, and part of having the ability to test those products is that the chemical companies insist on confidentiality agreements. And the other thing with this is you wouldn't anyway want to disclose potential products too early because these products cannot be used by growers until they're actually registered with the APVMA. So it may be interesting to know what the products are, but some of these products may never get registered because they're not very effective, and we will see that through the field trials. So there's not really a need to disclose what those products are until all the testing is completed.
The large majority of the work will be conducted in this trial by SRA, but the chemical companies that own these products will also be involved in the trials?
The chemical companies will be conducting their own research as well as an important, not add-on, but critical component of registration. And the work they will be doing will be looking at environmental testing of the products, because registration is not just about efficacy against canegrubs. It's about all the different environmental aspects. So the chemical companies themselves will be doing that work, which is also required for the registration process.
Some growing regions have experienced some additional canegrub pressure in recent time, and so one of the big questions we're regularly asked is how bad the canegrub numbers will be over the next year. Can you give an answer to that?
You can't really give an answer to that. Canegrubs themselves are affected by climate and weather conditions. So sometimes canegrub flights are early, and it all depends on the rainfall pattern. And sometimes you have multiple flights in a season. So all of these factors kind of compound to build up canegrub numbers. But there's so many factors that affect canegrub numbers. You can't predict what's going to happen in the field, so you can't actually say, we're getting flights at this time, so we'll get a high abundance. So many factors will impact both the beetle numbers, the egg numbers, the larvae or grub numbers. So it's not possible to accurately predict.
Kevin, the trials are all being conducted on commercial sugarcane farms. A big thank you and acknowledgement must go to the growers who did volunteer to host trial sites as part of this project, because without them, this valuable work would not have been possible. Let's hear now from one of these growers. One of the growers who generously has agreed to be part of the project is Steve Pillar from Guru, and we're standing on Steve's farm today. Steve, why did you decide to be a part of the project and assist SRA in this project?
I was approached locally by the manager in regards to the fact that I've never really had a major grub problem, but in the last couple of years I've noticed beetle numbers increasing around both of our farms where we never used to see many before. And knowing that we're going to be losing Imidacloprid, we need an alternative to take over from that, because I know some of my neighbours, and now that I'm starting to see some or very little effects of what the canegrubs can do on my farm, and seeing the neighbours plough out first, second returns, it's a little bit disheartening. and to the fact that that's productivity losses, and it's going to affect the whole industry, especially those in heavily grub infested areas. So for me, it was just a natural process to take this on.
Just how much of a concern is it finding a solution to replace imidacloprid?
It's critical in those areas that have heavy or high pressure from grubs and beetle flights. Without an alternative, we're going to see massive crop losses, and that's going to increase production costs, where you're looking at, on average in the Burdekin, you're probably looking at 3 to 4 returns. Some of us go a bit further than that. In those high pressure areas, we're not going to see that. There's going to be destruction of crops without some alternative there to replace imidacloprid to control the grub levels.
Obviously, being a part of the project, it takes time away from your day-to-day work, but you decided that it was worth it to be a part of the project?
It takes a little bit of time, a bit of organising, but on a whole, I'll give SRA credit. They run the project very smoothly. My main job is to inform them what I'm doing on farm and to farm in the best possible way I can and see the results from that. With trials like this year, we can't harvest the crop and send it off to the mill. Compensation is provided there, and it can be a little bit inconvenient, but the end result is we need a replacement. We need to find something out there that's going to replace what we have now.
Well, SRA, I know, appreciates growers like yourself being involved in our project, and thanks for joining me today.
Not a problem. Anytime, Sonia.
Kevin, you must be very appreciative of the growers like Steve who stepped up and volunteered to host trial sites.
Yes, without growers allowing us to use their property to do these field trials, we wouldn't be able to do the research. The chemical companies wouldn't be able to get scientifically validated field data to show that the products are effective. And products wouldn't be able to get registered without field trials. So the APVMA need the field trial data to consider before registering a product. So the growers are the integral part of this work, the foundational part. If we didn't have growers who are willing to support us and essentially support the whole industry, we wouldn't even get close to an alternative to imidacloprid. So I'm very grateful for their help with our work.
Absolutely. And I think you speak for all of SRA in that sentiment. Kevin, you've mentioned before that this project builds on years of foundational work focusing on the cane grub conducted by you and your entomology team. It's also running parallel to another project being led by SRA's entomology research scientist, Dr. Samuel Bawa. His project is focusing on a different stage of the cane grub's life cycle. Can you tell us more about his project?
Samuel's project it's focusing on the adult beetle, because essentially the adult beetle is the starting stage of the life cycle. You have to have adults which can produce eggs which can then hatch out into grubs. So Samuel's project is focusing on trying to disrupt the adult stage of the life cycle and essentially give us another potential control option in an IPM approach. If you could reduce adult numbers, then consequently you would reduce grub numbers as well. So Samuel's project is focusing on identifying volatiles released by plants where the adult beetles are attracted. So adult beetles are attracted to different tree species, and those beetles go to the trees to feed. Then they copulate and reproduce and produce eggs, and the females fly into the sugarcane field to lay the eggs. So if you can actually disrupt that stage, then you'll get less larvae produced.
When you talk about the volatile component, are you talking more simplified? Are you talking about the scent that that host tree gives out that attracts the cane beetle to that plant?
Yeah. Most plants release attractants for insects, or they can actually release deterrents. So they can release a chemical which attracts the beetle in, so they will all aggregate on the plant because they're attracted by the chemical. There are also other chemicals which can deter the adults. Samuel's project is actually identifying what chemicals are there from the host plant, what's released from the host plant.
Is the theory behind it that if we can mimic that volatile, we can make a synthetic option?
The theory behind it is if we can mimic or collect the volatile, and it may not be just one volatile, it could be a volatile mix, then we could use that volatile mix to develop lures or chemical lures to attract the adult beetles elsewhere. So to actually disrupt them and prevent them going into the sugarcane. So that's the theory behind it, but it's essentially an innovative 1-year research project. And what we will look at is, can we extend that work beyond the 1 year based on Samuel's findings?
His findings so far have been very promising.
Yeah, the findings have been really promising. He's actually looked at 3 different plant species. So one is sugarcane, and the other 2 are different fig species. And he's actually found that there are more chemicals released from the fig species than from the sugarcane. So it would appear that the volatiles released from the fig species may very well be acting as attractants. But the next stage in that type of work would be to test those attractants in the laboratory with cane beetles to make absolutely sure you've got the right volatile and the right concentration of the volatile to prove that it's attractive.
So after the lab analyses, and if he is able to establish one or more or multiple volatiles that will attract the cane beetles, what do you do with that? If we're developing a synthetic version of these volatiles, are we going to use that to put in traps to attract the beetles?
That could be one option, that you use it in traps, so you have trap lures for the beetles. Another thing, potentially you could develop a spray system. Ultimately, it depends on what the chemical is and, how expensive it is to produce that type of chemical. But it's early stages in the research, but if we can continue that type of work, we'll be able to target not only cane grubs using chemical insecticides, but adults using volatiles which are naturally produced by the host plants.
This project seems more of a preemptive tactic, a defensive move, while the Imidacloprid project is more of an offensive strike. If both are successful and you're attacking things from both sides, it will not only be a major win in the war against this pest and broaden the scope of integrated pest management for cane grub control, it would be a real game changer for the industry.
It would. I'd just point out that what we've done with Samuel's work is he's only been working on one species of cane beetle. So that's the greyback cane beetle, which is the most geographically widespread, the most economically damaging. So we would need to test these volatiles to see how effective they may be for the other beetle species as well. But ultimately, in the long term, it would be a game changer if you can target 2 parts of the life cycle and just disrupt the cane grub system.
It's certainly a project that I think all will be watching with intense interest. Kevin, thank you for joining me today and providing some more insight into both of these projects.
Thank you, and I'm glad the industry is supportive of this work. It's really critical to get an effective control against canegrubs, and we'll keep you updated.
Yes, SRA will certainly continue to keep industry updated on outcomes from both projects. If any listener would like to learn more about these projects, more information can be found on our website, sugarresearch.com.au. There you can also find a recent webinar featuring Dr. Samuel Bawa on his host plant volatiles project and hear more about SRA's soldier fly work. SRA would like to take this opportunity to again thank those growers assisting SRA in the Imidacloprid project, as well as the chemical companies involved in the trials. SRA would also like to acknowledge that the current SRA-funded Beyond Imidacloprid project is an extension of a previous 5-year Imidacloprid project funded by the Department of Primary Industries and Sugar Research Australia. Finally, thank you, our listeners, for tuning in to another episode of Cane Matters.